Hey guys, welcome back to my channel with a new lesson, and today's lesson is one of the most basic lessons in AP Calculus, which is the concept of limits. Today we'll be determining the limits numerically and we'll examine some of the limits that doesn't exist. So let's start off by what are limits. The idea of a limit is the basis of all calculus, and it's created by Sal Khan. And a limit tells us the value that a function approaches as that function's inputs get closer and closer to some number. So we'll start by determining the limits numerically. So let's read this. If f of x becomes arbitrarily close to single real number L as x approaches c from either side, the limit of f of x as x approaches c is L. What does that mean? This means that as x approaches c, limit f of x will be equal to L. So let's look into this. So here is c, okay? And this is x. So as x approaches c from either side, so which means that either from the left side or from the right side, f of x when it approaches c exactly will be L. So again, as x approaches c from either side, limit f of x is equal to L. Here is an example where we can understand it more. So here we'll have to find the limit as x approaches 1. So when x is 0.75, f of x is 2.31, and when x is 0.9, f of x is 2.7, and when it's 0.99, it's 2.9. So as we can see here that as x is increasing, the f of x is increasing too, right? And then when we look at it from the other side, when x is 1.25, f of x is 3.8, and when it's 1.1, it's 3.3, and when it's 1.01, it's 3.03, and it goes on and on. So as we can see here too, as x is decreasing, approaching 1, f of x is decreasing too. So from that we can find f of x when x approaches 1. How can we find it? Here when x is 0.999, which is very close to 1, but from the left side, f of x is 2.997. And when x is 1.001, which is very close to 1 again, but from the right side, f of x is 3.003. And this means that when x approaches 1, f of x should be 3. Why 3? Because 3 is in between 2.99 and 3.003. So let's get the answer. Yes. So when x approaches 1, limit f of x is equal to 3. And now let's take another example where the limit doesn't exist. So as we can see here, the limit when x approaches 0 doesn't exist. Why? Let's try solving it first. So when x is negative 2 over pi, f of x is negative 1. And when it's negative 2 over 3 pi, it's 1. And then when it's negative 2 over 5 pi, it's again negative 1. And if you look at it from the other side, when it's 2 over pi, f of x is 1, and when it's 2 over 3 pi, it's negative 1, and when it's 2 over 5 pi, it's 1. So as we can see here, and we noticed that it's f of x is going as negative 1, 1, negative 1, 1, negative 1, 1. What does that mean? It means that here we have an oscillating behavior, and for that we have a rule. Let's look into this rule. So the rule says that as x gets closer to 0, see, here x is getting closer to 0 time by time. So when x is getting closer to 0, f of x doesn't approach a number, which means that it doesn't exist, but either and instead it oscillates back and forth. So here it's oscillating negative 1, 1, negative 1, 1. So it's oscillating back and forth. So if the graph has an oscillating behavior, the limit doesn't exist at all. So here, because it's oscillating, so the limit doesn't exist when x approaches 0. Now let's take another example and determine the limit numerically. So in this example, we'll have to find the limit by substituting the values. So here it says that f of x is equal to 2x if x is less than 2, and f of x is equal to x squared when x is greater than or equal to 2. So here we'll have to find the limit f of x when x approaches 2 from the left side. Why 2 from the left side? Because here we have a negative. So this negative represents left. So when it's 2 to the power of negative, it means that when x approaches 2 from the left side. And then when it's positive, as in here, it means from the right side. So now let's find f of x when x approaches 2 from the left side. So when x approaches 2 from the left side, that means x is less than 2. So when x is less than 2, f of x is equal to 2x. So we'll take this and we'll substitute 2 in it. So 2 times 2 is 4. So here, when x approaches 2 from the left side, f of x is equal to 4. And then here in B, we have to find f of x when x approaches 2 from the right side. So from the right side means that x is greater than 2. So when x is greater than 2, f of x is equal to x squared. So here again we substitute 2 and x squared. So 2 to the power of 2 is also 4. So here we have when x approaches 2 from the left side and when it approaches 2 from the right side, both of them, f of x for them is 4. Let's take C now. So we have to find f of x when x approaches 2 exactly. So to find this, we'll have to look at it from the left side and right side, since we already solved for them. So as we said, when x approaches 2 from the left side, it's equal to 4, and when x approaches 2 from the right side, it's also equal to 4. So as both of them are 4, as in both of them f of x is 4, f of x when x approaches 2 is also 4. Let's take D now. So what is limit f of x when x approaches 1? 1 is definitely less than 2. So we'll substitute in this. So 2 times 1, we'll substitute 1 and 2x. So 2 times 1 is 2. So finally the answers are 4, 4, 4, and 2. So our answers are correct. Now let's take another example where the limit doesn't exist. So in this example, it says that f of x is equal to x squared plus 1 when x is less than negative 1, and f of x is equal to 3x plus 1 when x is greater than or equal to negative 1. So when x approaches negative 1 from the left side, it means here that x is less than negative 1. So we substitute in the first equation, which is this. So x squared plus 1, so it will be negative 1 squared, which is 1, plus 1, which gives us 2. So the answer when x approaches negative 1 from the left side, f of x is equal to 2. And then when x approaches negative 1 from the right side, which means that that x is greater than negative 1, so we'll use this equation and substitute in it, negative 1. So 3 times negative 1 is negative 3, plus 1 is negative 2. So f of x is negative 2 when x approaches negative 1 from the right side. Then here we have to find limit f of x when x approaches negative 1 exactly. So as I said, we look into negative 1 from the left side and right side and compare both answers. So we said that limit f of x when x approaches negative 1 from the left side is 2, and from the right side is negative 2. So they're not the same, they're different. One is 2 and one is negative 2. So this means that when x approaches negative 1 exactly, limit f of x doesn't exist at all. And now let's take D. So here we have to find limit f of x when x approaches 1 exactly. So when x approaches 1 exactly means that 1 is greater than negative 1. So we'll definitely take this equation, the second equation, which is 3x plus 1, and substitute for 1. So when we substitute for 1, 3 times 1 is 3, plus 1 is 4. So the answer for D is 4. So let's check our answers. So f of x is equal to 2 when x approaches negative 1 from the left side, which is correct. And when it approaches negative 1 from the right side, the answer is negative 2, which is also correct. And when it approaches negative 1 exactly, it doesn't exist. And when it approaches 1, the answer is 4, which is also correct.